Good morning everyone. In the previous video we have learnt about properties of ionic bond and ionic compound. Today we will discuss about the covalent bond. Covalent bond, as you know, is formed by the mutual sharing of it is formed by the mutual sharing of electrons, or we can define covalent bond as it is formed by the overlapping of orbital orbitals. This bond is basically formed by the sharing of electrons. We can share electrons by three types: single, double and triple bond. There are three types of covalent bonds: single, double and triple bond. Single bond is formed by the mutual sharing of two electrons. Double bond is formed by the mutual sharing of 4 electrons, and triple bond is formed by the mutual sharing of 6 electrons. Let's start with the single bond. As single bond is formed by 2 electrons, it is denoted as triple bond. How do you form the electron dot structure of the compound or the molecule which is formed by the single, double or triple bond? Let's start with hydrogen. Electron dot structure of number 1, hydrogen. In the ionic compound there is a transfer of electron, but in the covalent bond it is sharing of electron. Like the configuration of hydrogen, you know that it is 1 electron in cation or 1s1. So each hydrogen has 1 electron in its shell, outermost shell or shell. So this is formed by the mutual sharing. This electron this hydrogen share its electron with this, and this electron share its electron with another hydrogen. Here ring-like structure is formed. Here this zone is common for union zone. This is common for both the atoms. So in covalent bond this type of circle is formed. In electrovalent bond we use this type of arrow to denote the transfer of sodium electron to chlorine electron, but this is not formed here. You must make a circle of, so that the both of electron, the shared pair of electron, these two are shared pair of electron. So both the atoms share this pair of electrons, one by this hydrogen and another by this one. Take another example. Take example of chlorine. Chlorine, first you write electronic configuration. Chlorine 2h7. Outermost shell contains 7 electrons. Write chlorine and write outermost shell, electrons of outermost shell. There are 7 electrons. You must write this electron in front of the another chlorine. like this. This is 7 electrons. Now, this hydrogen, as we know that this hydrogen complete its duplet, 2 electrons is needed to acquire the helium configuration. So, only 2 electrons is needed for hydrogen to satisfy. But for chlorine, 8 electrons is required. So, this chlorine shared its electron to this chlorine. How it shares? There is a common place. 1 electron of this chlorine, another electron of this chlorine. These two chlorine. Now, this chlorine has 8 electrons. 7 and plus 1, 8 electrons. This chlorine also have 8 electrons. By writing this type of structure, we can understand that each chlorine has 8 electrons. This is completion of octet. Each and every element has tendency to acquire 8 electrons in their outermost shell. So these two are, and the bond formed here is, for hydrogen, the bond formed is single covalent bond, like single covalent bond, and bond formed by the chlorine is chlorine, chlorine. This is single covalent bond. In these two cases, sharing of only 2 electrons is present. There is only 2 electron and 2 electron. Sharing of 2 electrons means single covalent bond. So, and the rest of electrons are, here chlorine has 6 electrons which is not bonded. It is these pairs of electron. This one pair is called lone pair. Sometimes chlorine use this lone pair of electron for forming coordinate bond. Next example is oxygen. Let's take the example of oxygen. For has electronic configuration 2, 6. So each oxygen shared, how many electrons are required for completing octet? 2 electrons. 2 electrons are required to complete its octet. So oxygen shares 2 electrons. So you must write 2 electrons in front of the another oxygen, like this. 2, 4, 6. So this oxygen shares its 2 electron with this oxygen. So the bond formed is like this. 2, 4, 6 and 8. 2, 4, 6 and 8. So cover these 4 electrons. In this common place, how many electrons are present? 1, 2, 3, 4. Here 4 electrons are present. So the bond formed here is O, double bond O. It is example of double covalent bond. Double covalent bond means it must share 4 electrons with each other. Double covalent bond. One for this and another for this. There are 2 bonding, and the lone pair there are 2 and 4 lone pair of electrons is here and 4 lone pair of electrons here. Next example is nitrogen. Nitrogen, its configuration is 2, 5. So its outermost cell contains 5 electrons. How many electrons it needs to complete its octet? It needs 3 electrons. So this nitrogen shares 3 electrons with another nitrogen. 3 electrons. It has 5 electrons, right, like this, and for this 2 and 1, 2 and 3 electrons. Both if shares its 3 electrons, 6 electrons are there, 6 plus 2, 8. So octet is completed. So we must take care of forming the circle between these two. There are 6 electrons. So the bond formed is nitrogen with 3 triple bond. So it is the example of triple covalent bond, nitrogen. So these are the molecules of element which have covalent bonds. Now consider hydrochloric acid. Dot structure of hydrochloric acid. Hydrogen has only 1 electron and chlorine has 7 electrons. 1, 2, 3, 4, 5, 6 and 7. So this chlorine, this electron must write in front of the hydrogen. So this chlorine complete its octet like this by taking this, by sharing its electron is 1 electron with hydrogen, and hydrogen complete its octet by sharing 1 electron with this chlorine electron. So the bond formed here is HCl. This is single covalent bond because there are only 2 electrons, and these are lone pair of electrons. You must not need always to write hydrochloric acid. You can write hydrochloric acid, the structure of hydrochloric acid like this also. Next example is ammonia. As we know that nitrogen requires 3 electrons to share. So for nitrogen, write 3 electrons like this, and hydrogen like this. First complete duplate and then octet. 2, 4, 6, 8. Total is, and this is lone pair of electron present in ammonia. So the structure of is like this, and with a lone pair, hydrogen. In these two cases, all bond formed is single bond. Bond formed here is also single covalent bond. Take the example of CO2. Practice these dot structure 3-4 times. You must understand the structure, and if you have any query, ask me. For carbon, the electronic configuration is 2-4, and for oxygen electronic configuration is 2-6. It needs 4 electrons to share, it needs 2 electrons to share. So carbon needs 4 electrons to share. 1, 2, 3, 4. Right? And oxygen needs 4. It needs 4 electrons to share, and oxygen needs 2 electrons to share. So write 2 electrons here, and rest is like this, 2, 4, 6. And for carbon it is 2, 4, 2 and 4. So write another oxygen like this, 2, 4, 6. Here, to complete its octet, carbon has to share its 4 electrons, one with this oxygen and another with this oxygen. So here are 1, 2, 3, 4 electrons here, and 1, 2, 3, 4 electrons here. So carbon with carbon, we need to circle all 8 electrons. This is completion of octet of carbon. And now oxygen, this is completion of octet of oxygen. For this oxygen, 2, 4, 6, 8. So right from here, make a circle. Here, how many electrons are present? 4 electrons. And here, how many electrons are present? 4 electrons. You need not write this 4 electrons. This is for 4 electrons. So, this is 4 electrons means double bond. With oxygen, carbon, double bond. carbon double bond oxygen and carbon double bond oxygen. In both the cases there are 4 electrons. So 4 electron indicates that there are double covalent bond with lone pairs. You can write also like this: C double bond O, C double bond O. Next example is water. Try to make electron dot structure of water, H2O. For water, hydrogen, there are 2 hydrogen. So 1 hydrogen, oxygen needs to share how many electrons? 2 electrons. So 1 electron this side and another is this side. And rest electrons, write rest electrons in pairs like this. This is a electron of hydrogen. Must complete duplet first, duplet of hydrogen first, then 2, 4, 6, 8, completion of octet of oxygen. So bond formed here is only 2 electrons, so single covalent bond, and this is single covalent. Actually, due to these 2 lone pairs, water, the structure of water is like this. It is bending structure, bend structure, bend structure. So next example is ammonia. Next example is methane. So here are your home assignment. Write the properties of ionic compound. What are the properties of ionic compound? First question is write the properties of ionic compound. Covalent compound. Like ionic compound, write the properties of covalent compound. Covalent compound is as its bond is not very strong bond, so it is found in solid, liquid or gas. It dissolves only in organic solvent, not in inorganic solvents. So because covalent compound are only dissolving, like dissolves like, this is the law, like dissolves like. So covalent compound dissolves in covalent compound solvent only. Then it has very lowest electrostatic force of attraction. So its melting point and boiling point is lower than that of the ionic compound. It is directional. As we see that if it is carbon dioxide, we must write CO2 like this. We can't write CO2 like this or another type. It is a linear structure, a fixed structure of CO2 and a fixed structure of H2O as well. Due to the lone pair of electron, there is a bending of bond of hydrogen and hydrogen with oxygen. So there is a bending. So these compounds are directional. The structure of these compounds are directional. It do not conduct electricity. The compounds do not conduct electricity in molten state or in aqueous solution. For example, if you add alcohol in water and try to conduct electricity through it, it doesn't conduct electricity. So these are the properties of ionic compound. Write the properties of these are the properties of covalent compound. Write the properties of covalent compound. And the second question is, this is question number 1, and the second question is differentiate between, or write the differences between, covalent compound. Yeah, you can write ionic compound, ionic and covalent compound. And question number 3, this is your home assignment. Question number 3 is draw electron dot structure of structure of sodium oxide, magnesium chloride, carbon dioxide, water, CH4 methane and C2H4. This is ethene. Try to form the covalent bond between ethene. Next, these covalent bond are of two types. First is the single, double and triple bond, but these single, double and triple bonds also are of two types. Covalent bond is polar covalent bond or non-polar covalent bond. Polar covalent bond and second is non-polar covalent bond. This polarity, development of polarity is due to the difference in electronegativity. So you must understand first what is electronegativity. To understand the electronegativity, there are three terms I want to explain here. First is ionization energy. Second is electron affinity. And third is electronegativity. Generally, I discuss these three in the chapter periodic table. But to understand the polar and non-polar covalent bond, you must understand these three. We will discuss these three or polar and non-polar covalent compound or covalent bond in the chapter periodic table and organic chemistry. So our next, to understand the electronegativity, you can say that where there is some compounds have tendency, some atoms have tendency to attract. If it is hydrogen and chlorine, we see here that this is the bond formed in hydrogen and chlorine, but chlorine is more electronegativity. If we consider hydrochloric acid, chlorine has more electronegativity. It has tendency to attract this electron towards itself to some extent. Due to this, chlorine has a partial negative charge because it attracts this bond pair towards itself. So this is sharing pair. So this chlorine has tendency to attract these two electrons towards itself, so it is partially negative and hydrogen becomes partially positive. This type of bond is called polar covalent bond, and bond formed between ammonia, bond formed between hydrogen, bond formed between chlorine, bond formed between CH4 are non-polar covalent bond. We will discuss in the next chapter.